Hello and welcome you all. I, Professor Vipin Chopade, working as Assistant Professor at AISSMS Institute of Information Technology in Department of Engineering Sciences. In this video, we are going to talk about a manufacturing process, specifically forging. So what is the learning objectives of this session? At the end of this session, student must be familiar with the forging concept, types of forging operations, hot and cold forging operation, open die forging and closed die forging operations. Let's talk about the definition of forging first. Forging is the process in which metal is heated and is shaped by plastic deformation by applying a compressive force. Means it is the process in which metal is heated up to particular temperature and then that metal is beaten by either hammer blows or press machine to deform, and that particular force which is exerted on the heated metal is of the nature compressive type. The compressive force is in the form of hammer blows or power press. So forging refines the grain structure and improves the mechanical properties of the metal such as strength, ductility and toughness. As we have talked about casting already, casting components are having less strength as compared to forging. Why? Because in forging, it refines the grain structure and improves the mechanical property. This is the reason behind that. That's why forging components have better strength as compared to the casting components. Forging are consistent from piece to piece without any of porosity, voids and inclusions. As we have talked about casting, the heated metal when it cools down, generation of pores taking place. In forging, such is not happened. That's why forging components are having higher strength as compared to casting component. Again, the forged component have high strength to weight ratio and good surface finish. So these are the forging press machines. This one is the forging process in which your this is the topmost die, this is a bottom die, and in which a metal is placed. This heated metal is called as billet, over which a ram is pressed by using this cam and floor arrangement. So this is a drop hammer type of setup. Then this is same setup in which heated metal get forged down by applying a pressure from the screw press. So this is the setup where you have to apply the pressure on this heated metal by using a screw press machine. Then this type is again a forging machine type in which the pressure is generated using the crank press machine. So this is another type. Then the last one is hydraulic press in which the pressure is generated by a hydraulic fluid. So these are the types of the press machines which are observed. Then classification of forging process. There are two categories depending on the heat treatment which applied. One is hot forging, the second one is cold forging. The temperature above the recrystallization point is hot forging and the temperature below recrystallization point is cold forging. Means what? Hot forging carried out at a temperature above the recrystallization point and cold forging carried out at a temperature below recrystallization point. And what is the mean by recrystallization point? It is nothing but the temperature at which complete reorientation of a metal takes place. That particular temperature is called as recrystallization temperature. Then, depending on the types of dies used, forging is classified into two categories. One is open die forging, the second one is closed die forging. In open die forging, the metal is deformed or forged down into two flat dies surfaces of very simple shape. It is called as open die forging. And in closed die forging, the metal is deformed between two dies which have the impression of certain desired shape. So this is closed die forging. When two cavities are closed, the cavity is formed of the desired shape. This is closed die forging. Diagrammatically, see here, this one is the open die forging and this one is the closed die forging. In open die forging, both dies are simple and flat surfaces, While in closed die forging process, certain impressions are present on the die surfaces. So this one is your closed die forging process. Then hot forging and cold forging. As we have talked about already, hot forging is the process in which it carries out at a temperature above the recrystallization point. That is called as hot forging. And what are the advantages? That it will produce a discrete part. Then the accuracy is low to medium. Then the stresses which are generated in hot forging are low, and the grain structure which is observed is homogeneous in nature. So these are the advantages of hot forging. What are the disadvantages? The low precise tolerances are observed. Possible warping of the metal during the cooling process is observed. So these are the disadvantages. And the application areas of hot forgings are connecting rod, gears for motorcycle, fan, fuel injection parts, again structural components in transportation equipments such as submarines, railroads, crankshafts. So these are the applications areas of hot forging. Next one is cold forging, the process which carried out at a temperature lower than that of the recrystallization temperature are cold forging process. Then the advantages of cold forging, that it is it handles the high stresses and high die loads. Then it is having a high dimensional control. Then it will produce a near net shape part. So these are the important advantages of the cold forging process. Then disadvantages are stronger tooling is required. Residual stresses may occur at the end of the cold forging process. So these are the important disadvantages. And the products which are obtained from the cold forging processes are nut and bolts, fasteners, slewings, coinings, etc. These are the products which are obtained from the cold forging process. So this is the difference between them. As we have talked, first the temperature is above recrystallization point in hot forging, while it is below that of the recrystallization point at cold forging. Then preferred for steel and steel alloys. Then it is preferred for aluminum and its alloys. Then for hot forging, production of discrete part is observed. Then production produces net shape and near net shape parts is observed. In hot forging, accuracy is low to medium. In cold forging, accuracy is high. Then in hot forging, highly grained structure increases the strength of the metal, while in cold forging, residual stresses are developed in the cold forging processes. Then final finish product is produced in hot forging. The end product required finishing. Possible reaction between surrounding atmosphere of the metal takes place because of the higher temperature in hot forging, and reaction in atmosphere and metal is not observed at room temperature in case of cold forging. Less precise tolerance on the end product is observed in hot forging, while increased dimensional control on the end product is observed in cold forging. Cost of the hot forge component is high, cost is low, and the application areas in connecting rod, gear, fan blades, or forge components are observed, while nut, bolt, and fastener cold forge components are observed. So these are the differences between hot forging and cold forging. I hope now you will be familiar with the definition of forging, the types of forging process depending on the temperature, and the types of dies are used. Thank you. Thank you all.